to have kids. Whereas today, we've got antibiotics and vaccines and all that other stuff, and hygiene and so on. So you tend to be able to get away with having a weak immune system. The selective pressure not to have a weak immune system is considerably less strong than it used to be. So sure enough, we've ended up with people having a weaker immune system, and that's why we get things like more autoimmune difficulties and such like.
There are some people that feel strongly that the evidence is also showing that vaccines have contributed greatly to weakening our immune systems, giving 10 and 15 shots to young babies.
But you've got to also accept that vaccines have saved lives. You know, the fact is people live longer than they used to. People die of infectious diseases a lot more rarely than they used to, right? So, it's a trade-off, but it's a trade-off that has worked out in our favor on balance.
So the immune part you see over like an evolutionary period of time, how our immune systems have changed.
Right.
Okay.
And let me be clear about what I mean by an evolutionary period of time. The fact is this has been relatively rapid over a few generations. The one reason why it's been particularly rapid is because it turns out that women with a weaker immune system are more fertile. That actually makes a good deal of sense in terms of what we know about the immune system, because we know that the fetus is, immunologically different from the mother, and therefore the immune system has to be in control of itself, so to speak, in order not to treat the fetus as an infection. And the weaker the immune system is, the more likely the mother is to be able to do that.
Interesting. You talk about the side effects of metabolism will eventually kill us with regard to aging. What do you mean by that?
Well, I gave one example earlier, the fact that breathing is bad for you. So let me go into a little bit more detail on that. What does breathing actually mean? The chemistry of breathing, the reason why we need oxygen and why we breathe out carbon dioxide, is pretty well understood by now. Essentially what the situation is, we have a particular part of the cell, it's called the mitochondrion, and it's responsible for taking oxygen that has come in through the lungs, obviously, and then through the red blood cells, and combining that oxygen chemically with nutrients, carbohydrates and fats and so on. And that process of combining the oxygen with nutrients releases energy from the nutrients. That energy is then used for all the things that go on in the body, like, the replication of DNA and the synthesis of proteins and so on and so forth. But the thing is that actually that chemical process is incredibly hairy. It's a really tricky thing that involves a great deal of elaborate use of metal ions and things like that. And the result is that sometimes it goes wrong. Sometimes the chemistry of breathing causes electrons, in fact, to get into the wrong place, so to speak, in the chain of events, and to create molecules that we wish they would not create. The molecule that really starts this whole chain of events is something called superoxide, and that's a free radical, and it reacts with other molecules to create other free radicals, which have a strong tendency to damage our important long-lived molecules like DNA. So, that's one of the best examples, in fact, probably the number one most important example of why metabolism, our normal processes of living, are things that we can't live without, but we also can't live all that long with.
I think that would be a great thing. So what would you propose, given your experience now and your focus in this area? What would you propose happen with regard to settling that area that goes wrong and produces free radicals with breathing? Do you feel like you're onto something yet?
Oh, absolutely, yeah. So it's a fine example. So that's actually a great example of what goes wrong with the normal approaches that people have previously been thinking about in relation to combating aging. Most people have said, well, okay, so free radicals are bad for you. Breathing causes free radicals. We've got to breathe, so we're going to have free radicals be created. But maybe we can somehow tweak our metabolism so that breathing happens in a manner that does not actually create quite so many free radicals as normal, right? And so that's obviously a way to go forward in principle, but it's got two problems. Number one is that all it's doing is slowing down the accumulation of the various types of damage that free radicals cause. Okay, it's not getting rid of pre-existing damage. Number two, a second problem, is that it's really, really, really difficult. The fact is, it took evolution a very long time to come up with a system for getting oxygen to combine chemically with nutrients to extract energy that's as safe as it is, that creates as few free radicals as it does. And improving on that is simply beyond us at this point, way, way beyond us. So that's really a problem. And I realized that actually we can avoid this problem. We can sidestep our ignorance, if you like, by instead going in and not trying to actually affect the creation of free radicals at all, but going in one step later down the chain of events, looking at the various types of damage that the free radicals do after they've been created, things like the oxidation of DNA and the oxidation of proteins and so on. And, that's an alternative option, because that is the problem. The free radicals themselves are not the problem. The problem is the damage that the free radicals do. So if we can repair that damage, then that's just as good as stopping the damage from happening in the first place. And in fact, it's better because we can use therapies on people that have already accumulated a whole bunch of that damage, and we can actually repair that damage after the fact. So we can take someone who's, let's say, 60 or 70 years old and use therapies on them that had not been invented when they were only 20 or 30 years old, and yet we can still take them back to being biologically 20 or 30 in terms of the level of damage that they're holding.
It's a whole different paradigm, isn't it?
Oh, yes.
Do you find more and more people are open to you and your work?
Oh, very much so. It took a while for people to really, get on board with all of this, and that's no surprise, because the fact is, the way of looking at this way of looking at it is somewhat counterintuitive. A lot of people took the view, well, look, reversing aging sounds like a great idea in principle, but it's obviously it is to be defined, it's obviously harder than slowing aging down. And, it sounds as though it's obviously harder, but it's not, because, of course, repairing aging does not actually follow, if you like, the exact, it doesn't retrace the steps that, the chemical steps that the initial creation of damage took. It's a repair process instead of a reversal process. The other reason why it was difficult for me to really get this across to people is that when we come down to the actual nitty-gritty, the actual details of how one might repair these various types of damage, the types of biotechnology, the types of biomedical expertise that I brought to bear on these problems were areas that had typically been developed for other reasons. They had not been developed by people who were studying aging, but rather by people who wanted to solve other biomedical or biological problems. And that meant, of course, that the people who were studying the biology of aging did not have very much familiarity with the work that had already been done, which, of course, led to their being unduly pessimistic about how much work there was that was still left to do. But yes, over the past several years while I've been pursuing this, I've been able to address that problem really very effectively. Essentially what I've done is brought the various people with the various specialities together and allowed them to effectively educate each other and realize that this is something that is definitely very much on the table and cannot be rejected out of hand.
It's very interesting. Do you take a lot of supplements yourself?
I don't, actually. And I think it's important to understand why I don't, because I don't necessarily think that supplements are a bad thing, a bad idea. But I do think that the decision whether to take supplements in general, or indeed any particular supplement, is one that needs to be taken without generalizing. In other words, the biggest thing that one needs to take into account is one's own metabolism. One really has to listen to one's body in order to make these decisions. So, a comparison that's often made, a contrast that's often made between me and Ray Kurzweil.
Yes.
Ray, of course, is famous for taking an insane number of supplements. And,
yes.
I say it's insane, but I don't really mean that, because the fact is that he's probably right to be doing quite a lot of supplementation. He started out back in the 1970s, early 1980s, with a bad problem. Namely, he came down with type 2 diabetes, and that was when he was in his 30s, right?
Right.
So, that's not normal. Most people don't do that. It's not unknown, but it's pretty unusual. And furthermore, he has lots of cardiovascular disease in his family.
Yeah, his dad died of a heart attack.
Right, exactly.
Right.
So, it's a serious problem. And when he came down with diabetes, he submitted to the standard of care at that point, the standard treatment,